It's incredible how many devices around us today are powered by electric motors. Before we get started, if you want to support us, don't forget to leave a like at this video and subscribe to our YouTube channel. Whether it's a simple blender, a vacuum cleaner, a fan, or even a car or public transportation, electric motor is part of our everyday life. The most common engines use internal combustion to create heat. This is not the case with electric motor. Electric motor is powered by a complete different principle. Don't you believe me? Looking at this animation, you can see a wire connected to a battery. When the electricity flows through this wire, an electromagnetic field is created. This means that the electricity has temporarily turned the wire into a magnet. When the wire is disconnected from the battery, it's not a magnet anymore. If we hook it up the opposite way, its north and south pole reverse. An electric motor makes this process over and over, using the magnetic force to create mechanical motion. Now, let's take a step back to explain in details the basic elements of this process. Electric current is a flow of electric charge, which means moving electrons in a wire. Their motion is caused by electric potential difference between 2 points of a conductor. This difference allows the electrons to flow from the negative pole to the positive pole. A conductor is an object or type of material that allows the flow of an electrical current in one or more directions, like metals and alloys. A magnet is an object that produces a magnetic field. Each magnet has a north and a south pole. Inside a magnet, there will be always a south and a north pole, even dividing the magnet into 2 parts. The remaining parts will have a north and a south pole. A magnetic field is invisible, but is responsible for the most notable property of a magnet: a force that pulls on other ferromagnetic materials such as iron and attracts or repels other magnets. Many materials can be magnetized. It seems that Archimedes tried to magnetize the Syracusan army weapons in order to easily disarm the enemies. Electric motors require electricity for their functioning. The common plugs and sockets represent alternative current, an electric current which periodically reverses direction. Batteries represent direct current, an electric current which flows only in one direction. It's harder to enumerate the long list of inventors who tried to make practical the conversion of electrical energy into mechanical energy. In any case, we can draw a timeline of the most significant inventions for the development of today's electric motors. In 1800, for the first time, Italian Alessandro Volta produces a continuous electrical power from a stack of silver and zinc plates. In 1820, Hans Christian Ørsted notices that electric current is able to create magnetic fields. In 1821, Michael Faraday, with his famous experiment, shows that continuous electromagnetic rotation is resulted by suspending a magnetic wire in an electric field. In 1825, William Sturgeon invents the electromagnet, a coil of wires with an iron core to enhance the magnetic field. In 1831, Joseph Henry builds a small magnetic rocker. He describes it as a philosophical toy. In the same year, French instrument maker Hippolyte Pixii builds what can be considered the first apparatus for generating an alternative current out of a rotation. In 1834, Italian physics professor Giuseppe Domenico Botto creates a device corresponds to a metronome, acting on the pendulum with the two electromagnets. In the same year, Moritz Hermann Jacobi builds an electric motor able to lift a weight of 10 to 12 pounds with a speed of 1 foot per second. In 1842, Robert Davidson manages the construction of the first electrically powered car. Its engine reached a speed of 4 miles per hour. It's in 1856 that Werner Siemens builds an electric generator with a double T armature winding. He's the first one to place a winding into slots. This invention marks a turning point in the design of electrical machines. Today, almost all electric motors are built with the winding in slots. In 1885, Galileo Ferraris builds the first induction motor. In 1887, Friedrich August Hasselwander is the first one to come up with the idea to use a three-phase alternative voltage and current system. In 1891, Michael D'Olivo Dobrovolsky builds the first three-phase cage induction motor. Today, there are many different types of electric motors as well as many different manufacturers. Here are some examples. Finally, if you found this video useful, let us know by leaving a comment and subscribing to our YouTube channel to stay tuned on the release of new videos. Thanks for watching.